Okay, let's dive right into this explainer. We're going to treat this as an urgent, real-time situational awareness briefing for the anomaly that's currently unfolding over the North Pacific. Right now, somewhere out over the open ocean, the atmosphere is basically breaking a physical rule. You wouldn't know it just by looking out your window, but a massive system is intensifying at a rate that is setting off alarms across multiple forecasting agencies. We're tracking a combined megastorm event that's going to test the absolute limits of modern infrastructure. We've got a ticking clock of roughly 48 hours. So here's our agenda for this briefing. 1. The developing threat. 2. History as prologue. 3. The cascading failure. 4. Science versus infrastructure. And finally 5. The closing window for action before this system makes landfall. Section 1. The developing threat. The global weather models are showing a really high-confidence signal of a system that's essentially feeding on itself. And it all begins with a very specific, rapid collapse in atmospheric pressure. You know, when models agree this clearly and repeatedly across multiple consecutive runs, the atmosphere absolutely tends to follow. Now, you've probably heard the term bomb cyclone. The technical term is explosive cyclogenesis. Basically, this inward and upward rush of air creates a steep pressure gradient that rapidly accelerates wind speeds across hundreds of miles. To picture this physically, visualize the pressure map spiraling inward, exactly like pulling the plug on a bathtub drain. The water spirals inward and accelerates as it approaches the hole, right? Well, a bomb cyclone does the exact same thing with air. It creates these violent surface winds as the pressure at the storm's center drops way, way below the pressure at its edges. What's genuinely alarming here is that the current low-pressure system has already dropped 16 millibars in just 48 hours. And NOAA's latest runs project it's going to meet that explosive threshold well before hitting the coast. This isn't just a prediction of a bad storm. It's a real-time measurement of a system that is rapidly intensifying toward its absolute maximum potential. But honestly, the cyclone is only half the threat. We're tracking a literal river in the sky aligning perfectly with the low-pressure system, and it's carrying roughly 25 times the discharge of the Mississippi River. These two structures, the cyclone and the atmospheric river, they don't just add their effects together when they hit a coastline. They multiply. They amplify each other. The cyclone provides the high-speed wind, and the river provides this insanely dense reservoir of moisture. The integrated vapor transport reading right now is sitting at over 1,000 kilograms per meter per second. That is an extreme threshold, pushing the system toward a category 4 or 5 on the Ralph scale. Just for some context, an IVT value above 250 makes an atmospheric river. Anything above 750 is considered extreme. We're looking at a system exceeding 1,000, which means it's bringing exceptional and primarily destructive conditions right to the impact zone. Section 2. History as prologue. To really understand what happens when a powerful offshore pressure gradient amplifies an intense reservoir of moisture like this, we've got to look at what the atmosphere has already done to this coast. The atmosphere has shown us its capabilities before, and it is gearing up to do it again. History isn't just a warning here. It's a very clear pattern. It shows us how these extratropical systems utilize baroclinic instability to deliver catastrophic wind and cumulative soil saturation. Back in 1962, the Columbus Day storm hit with a brutal 962 millibar pressure, bringing 170 mile-per-hour gusts that literally flattened commercial timber. In 1989, repeated atmospheric rivers pushed Sacramento's levees to within inches of overtopping. And in 2018, Winter Storm Grayson dropped 33 millibars in a single 24-hour period, racking up $5 billion in damage. These explosive events are intensifying faster than they did in previous decades, heavily influenced by a warming atmosphere that's simply holding more moisture. Section 3. The cascading failure. The crucial point to remember here is that modern infrastructure doesn't just fail all at once. It fails in highly predictable, compounding layers. We have to think in cascades, where each single point of failure unlocks the next one in the chain. So a sustained 75 mile-per-hour wind applies 160 pounds of force per square foot. That is easily enough to topple a 4-ton Douglas fir right into the power grid. And keep in mind, the Pacific Northwest and Northern California have some of the highest urban canopy densities in the entire country. You can't predict exactly which tree will fall, but the physics pretty much guarantee that many of them will. And here is how that cascade actually unfolds in real time. Random wind damage triggers a massive grid failure. That subsequently neutralizes the electric-dependent water and medical systems all at the same time. When the power drops, water treatment plants switch to backup diesel generators, but those usually only hold about 72 to 96 hours of fuel. Once that runs out, You get boil orders in homes that have no electricity to actually boil the water. Meanwhile, home oxygen concentrators and dialysis systems go dark, which surges 911 calls at the exact moment when the roads are completely blocked by debris. Data from the Edison Electric Institute confirms that storms causing simultaneous outages for over 500,000 customers require an average of 11 days to restore. 11 days where life-saving equipment is dead. We aren't talking about a rough 3-day weekend without Wi-Fi here. We're talking about a fundamental infrastructure collapse that compounds every single day the grid stays offline. Now compound that grid failure with massive soil saturation. The atmospheric river brings a fundamentally different category of risk: catastrophic landslides that sever the only physical lifelines to mountain communities. The soil doesn't care if it's a 1 in 10-year storm or a 50-year storm. It only responds to what it's already holding. And right now, these watersheds are holding above average moisture. When landslides close vital single-route corridors like Highway 1, entire communities are functionally cut off from fuel, groceries, and medical aid in an instant. Section 4. Science versus infrastructure. Let's look at how our state-of-the-art predictive science clashes violently with the reality of our aging physical build. This is essentially where the unstoppable force of modern weather meets the highly movable object of mid-century engineering. We've made qualitative leaps in monitoring that actually allow forecasters to brief utilities 36 hours before landfall. The GOES West satellite can track the system every 60 seconds in high resolution, and air Recon aircraft are literally dropping sensors inside the atmospheric river as we speak. But all that world-class data is defending a grid that was built for a much milder 1970s climate. 31% of regional high-voltage transmission lines are well past their 50-year design life. The atmosphere is warming, meaning it holds about 7% more moisture per degrees Celsius. That puts hydraulic loads on earthen levees far beyond what mid-century engineers ever designed them to sustain. There are over 200 levee systems in California alone rated at high or very high risk. These were designed to protect small farming towns, but today, they're the only thing standing between these intensified atmospheric rivers and massively expanded urban populations. If a maximum category atmospheric river targets the Central Valley and breaches those defenses, peer-reviewed estimates project economic and supply chain losses exceeding $725 billion. That is a staggering figure. It really highlights how our natural systems and our human logistics are deeply, dangerously intertwined. Section 5. The closing window. The atmosphere has made a commitment. The warning window is rapidly closing, and the time for macro-level engineering fixes has officially run out. We are now entirely in the phase of immediate, practical preparation. Over the next 48 hours, as these moisture-laden winds slam into the coastal ranges, a process called orographic enhancement is going to multiply rainfall totals by 3 to 5 times. The mountains basically act as atmospheric vapor traps. They violently wring out the saturated air mass as it's forced upward over the terrain. So your immediate response has to be incredibly practical. You need to rely on your direct local knowledge of your neighborhood's specific vulnerabilities, rather than just refreshing a weather app. You need to know exactly where your utility shutoffs are, and you need to rely on your own memory of which local roads typically flood or slide when the heavy rains come. The average household usually only has about 12 hours of water on hand, but FEMA recommends 72 hours. That's a baseline that could literally save your life if treatment plants exhaust their diesel reserves. Moving from 12 hours of water to 72 hours just takes a quick trip to the store right now, but it bridges the critical gap before organized emergency aid can actually reach you. Most fatalities from these types of megastorms actually happen in the 72 hours after the storm passes. It's due to exposure, accidents, and medical crises. That makes preemptive community check-ins far more effective than just waiting around for official aid. You need food that doesn't need a stove or a fridge. You need a battery backup plan for a CPAP or insulin, and most importantly, you need to check on your vulnerable neighbors before the wind starts tearing trees down. Which brings us to the final reality check. The global supply chain runs right through this impact zone, meaning this storm affects us all, whether you live right on the coast or across the country. So taking a hard look at your own household right now, are you actually ready for the cascade? Or are you just hoping the lights stay on? We have the science, we clearly see the threat, and the atmosphere has committed to its path. The only variable left is what you decide to do in the next 48 hours. Let me know your thoughts down below.